Now I'd like to do a problem. I'll go over the problem quickly, and then I'm asking you to pause it and work on it a little bit by yourself, and then I'll go through the solutions. But the idea is that you start with a capacitor that has no charge on it, and then you have to charge it. And the question is, what do you have to do to charge it? And draw the circuit diagram. You'll need a battery. So then you're going to remove the battery, and then you have to figure out what's going on with the charge on the capacitor. Now what you have to do is pull the plates of the capacitor apart by a small distance. And the question is, what does that do to things like the electric field, the potential difference, the capacitance, the energy, and things like that? So pause the video right here and work on this problem. Now I'll solve the problem. So the idea is to charge a capacitor, you have to take your capacitor plate like this. It's uncharged at the moment. And then you have to attach a battery to it to charge it. So it looks like this. And then with the orientation of the battery this way, the left plate of the capacitor will become positively charged. In the next step, you remove the battery, and you're asked what happens to the charge in the capacitor. So in other words, pull off the battery. What happens to the charge? Well, there was charge on the capacitor to begin with, and once you've pulled off the battery, there's nowhere for the charge to go. So it's plus Q here and minus Q over here. So the charge remains the same on the capacitor plates. Now the idea is to take this capacitor plate and pull the plates apart by a small distance. So I'm now going to shift the plates apart like this. So D increases. And if you did that, what happens to the charge on the capacitor plate? Well, nothing. You just pull the plates apart. I think already you can kind of see that it takes work to pull the plates apart. So if it takes muscle on my part to pull the plates apart, it means that the potential energy of the system ought to increase. And we'll see that with the equations later. Now my question is, what happens to the electric field between the plates, and how do you know it? Well, one way to figure that one out is to recall a formula for electric field of a conductor. So you can remember this one, E equals sigma over epsilon naught for a conductor. And in this case, the sigma, which is the charge density, doesn't change because the plate has the same area, and then the charge didn't change, so the sigma is constant. So that implies that the electric field didn't change when we pulled the plates apart. Okay, then the next thing is what happens to delta V when we pull the plates apart. So you have to figure out a good formula that might utilize delta V. Hopefully you came up with this one. Delta V equals E times the distance. And what you see is that the E's remain constant when you pull the plates apart, but the D increased. So that means that delta V increases between the plates. The next question is, what happens to the capacitance? So there are several capacitor formulas, and you have to find the best one. Well, one of them you just try all of them, but here's one. Q equals CV, or C delta V. And you have to see if that's going to help. So Q stays the same when you pull the plates apart. Delta V increases. So that tells you something about the capacitance. The capacitance has to decrease. The other way you can think about it is C equals A epsilon naught over D. The A stays the same. The epsilon naught is a constant. The D increases, so therefore C decreases. Okay, so that's another way of doing that question. And then finally, what happens to the potential energy in in between the plates? Well, we said before that when you pulled apart the plates, it took muscle to do it, so the energy ought to go up. But there's a way you can do it with equations, so you have to think of one of these equations. Just try something. So we can try this one, for example. We know that the Q stays the same, the C goes down, and that tells you that the U has to go up. So this is a good problem for working through a lot of your formulas.